Hey, fifth grade. I'm just going to take some time here to recap our workbook 137 to 140. We did this yesterday, the last day of February. I was gone, so we had a sub, and it's nothing against substitutes because Mrs. Larson is amazing. But I know that sometimes just hearing your teacher's voice and the way, the way I kind of usually explain things and whatever just can be a little bit of a comfort. But hopefully, you learn some cool new ideas and strategies from Mrs. Larson and you'll be just fine. So if you missed yesterday's class like I did, you're in luck. And if you just want a little refresher, if something kind of scared you or you felt nervous about anything, I'm hoping that this will help you learn and help your heart just ease your fears as we go through it. Okay, Mark and his friends are putting on a play. Hooray! Mark is in charge of the costumes. He measures each sleeve in one costume to be 3/4 of a yard long. Each sleeve should be a half yard long. By how much should the sleeve be shortened? And they want us to draw a visual model. So of course we've got like our whole thing, right? And I'm going to split it into fourths. That could have been more equal, but we'll pretend it's so lovely. So you've got a fourth here, fourth here, right? So all of these fourths add up to one whole normal sleeve. Okay, and it says each sleeve is 3/4 of a yard long. So you've got 1, 2, 3/4. Okay, and each sleeve should really only be half of a yard long. So this is what he needs, right? 1/2. And this is what he has, that big purple chunk there. How much should the sleeve be shortened? He needs to chop off 1/4, right? So they need to be shortened by 1/4 of a yard. And of course, we know that we can represent this. Sorry, I have to scroll down here. Here's where they have us kind of repeat things. So 1/4 of a yard. Okay, another way to represent this, which some of you have already caught because you're just smart cookies like that. Really start with what he has, right? 3/4 of a yard. I'm going to try to make it up and down here for you. And we need to take away something. So we end up with, oops, 1/2 of a yard. So 3/4, take away something. So he ends up with 1/2. This is kind of choppy, sorry. Okay, so let's talk about fourths here because we don't have a common denominator. This is kind of a more complicated way to do it, but yeah, 3/4 minus what leaves you with 2/4. Well, 3 minus what is 2? It's a 1. Your denominator has to stay the same. So that's one way you could solve it. You could start with that 3/4 take away half, and you'd end up with this fourth. 3/4 take away that 2/4. Different ways to solve it. That's one of my favorite things. It can be a little daunting, but that's one of my favorite things about math is that you can solve something in different ways and still come to the correct answer. Page 138, number 1. Anderson and Joanne sold tickets for the play. Anderson sold 3/4 of the roll. Joanne sold 1/6 of the roll. What's the difference? Okay, difference means subtract. What's the difference between the fractions of the roll of tickets that Anderson and Joanne sold? Here's a model here. Letter A, explain what the dashed box in the fraction model represents. Well, it represents what's missing, right? It represents the difference. It represents the difference, what's missing, okay? And essentially it's showing us, this will help you with some worksheets too, that you've got 3/4 and you're gonna take away that 1/6 and whatever's left in that box would be the difference between those two fractions. Who sold more tickets? How do you know? Well, Anderson sold more tickets because we know that 3/4 is much more pizza than 1/6 of the pizza, right? Plus, look at the visual. So Anderson, how do you know? Oops. Oh no, I clicked something here. Oh no. Yikes. That was a video of a song a friend sent me, and it's really pretty. But anyway, okay. Who sold more tickets? Anderson sold more tickets. How do we know? Well, we can see that the 3/4 fraction strip is bigger than the 1/6 fraction strip, right? Letter C, use the fraction part in model A to draw fraction strips in the dashed box to solve the problem. Okay, this one gets kind of trippy, but if you notice here, so we've got this 1/4 stretch, 1/6 of it leaves us with this extra little piece. So if we chop that 6 in half, every time you chop a fraction in half, the denominator doubles, but the portion splits in half, okay? So like let me switch this here, from here to here, that's 1/2, right? And you split that half of a bar in half again, it gives you fourths. So if we split a 6 in half, we actually have 12ths, okay? So here's a 12th, split this fourth into 3, like right here, that's 3/12. We're pretending my fractions are so perfect. Split that fourth into 3. Each of these sections represents 1/12. Okay, so we can add them together. We have 1, 2, 3, 4, 5, 6, 7. And we've got 7/12 is what the difference is. Oopsie, I'm ahead of myself. Use the fraction. What fraction size strips would you draw? Sorry about that. So we're actually going to draw 12ths in there. Okay, so that stays up here. 12ths. Explain. Well, split the 6 in half to get 12ths, plus that's just what fit. Okay. What is the difference? Here's where we answer it. It's 7/12 of the roll of tickets, or just 7/12 of the roll if you want to keep it simple. Number 2. 2 boxes have the same number of play programs. On the first night of the play, Diana handed out 2/3 of the box. On the second night, she handed out 5/12 of the other box. On which night did Diana hand out more programs? How much more of a fractional part of a box did she hand out? Okay, so we've got thirds here and we've got 12ths. So looking at this, I notice we don't want to make our bigger looking denominators smaller. We always want to take the smaller number of the denominator and make it bigger. Sometimes you have to do that with both, but anyway. So I'm going to take that times 4 to make it a 12 so I can easily compare this. So 2/3 is really, it's the same as 8/12, but now look how easy it is to compare them, right? So the first night was 8/12, and really you guys could write this down here. I just don't have room, as you know, sorry. And the second night she handed out 5/12. Okay, 8 out of 12 is more pizza or more plate programs in this situation, but you know how much I love pizza. 8/12 is more than 5/12. So on which night did she hand out more? The first night. How do you know? Well, oh, that's down below. Sorry. Draw a visual model. You guys, you were so patient with your teacher. I'm sorry about this. Okay, letter A. So we've got the first night. Well, we figured out that I hope it was 8/12. Now I can't remember. I erased my work. Is greater than 5/12. Let me double check here. Yes. Okay. 8/12 is greater than 5/12, which is to say 2/3 is bigger than the 5/12. Okay, it's the same thing. We just made it look different so we can easily compare. Okay, how much more of a fractional part did she hand out? I'm going to backtrack here and do my visual part for you. Okay, so here's like the whole box, and we're dealing with 12ths, and I'm not crazy good at those, so I'm just going to take it piece by piece. So there's half, here's fourths, okay, and just really pretend they're lovely. And if I draw 3 lines in each fourth, that'll give me 4, 8, 12. Oh, nope, I did that wrong. Okay, I need to draw 3 like sections. So 2 lines, so you get 3, 6, 9, 12. There we go. Okay, so 2 lines in this fourth, 2 lines in this fourth, and 2 lines in the last fourth. All right, so now, okay, double check, make sure you have 12 spots, because if not, then we just have to fix that a little bit. Okay. So that first night she did 2/3, and actually this kind of works nicely, right? So like there's a third, and 4, 4, and 4. So if you split 12 into thirds, you've got, oh dear heavens. So you're going to color this really nicely. You know, I'm struggling, but the first night was 2/3. The second night, she had 3/12. So of that, you've got 1, 2, 3 out of 12. Okay. And how much more did she sell the first night compared to the second? So if the whole thing was the first night, here's the second night, right? She had that 3 out of 12. So essentially, we're going to cross this off. Okay, and the difference. Oh no, I kind of did this funny, didn't I? 5, oopsie. I kind of did it backwards, sorry. It was not 3/12 the second night. This is tricky when you can't see your original problem up there. Okay, so the second night she handed out 5/12. Sorry, so you do 1, 2, 3, 4, 5. Sorry, that's where that comes out as you cross that off, and you end up with this chunk of 3/12. Okay. And if that was kind of confusing, you can rewatch it. Sorry, I get ahead of myself and then it gets all sorts of silly. So you've got 3/12 more. Okay, so how did we do this? Well, split the rectangle into thirds, then shade 2 of them. So that shows what she sold that first night, right? Then we divided the fraction bar into 12ths. And we crossed out 5 of those 12ths, and there are 3/12ths left. Okay, number 1, Maria is in charge of the scenery for the play. I like that they include some arts in this. That's great. She paints 11/12 of a board green or blue. If she paints half the whole board, or half of the board, if you will, how much of the board that she paints is green? Draw a visual to model this. So most of the times you guys know how to solve these, and it's just the whole modeling process that can be a little bit daunting, a little scary, a little tricky. But with some practice, you will do just fine. Okay, so she paints half of it blue. And I really want to color coordinate this. So half of it is blue. Try to make that look lovely. And then 11/12 green or blue. No, 11/12 green or blue. So 11/12 is your total amount painted, and then half of that whole thing is blue. So the rest is green. Okay, so I split it in half. We're dealing with 12ths. So splitting a half into 12, so we want to make 6 little like bar snippets here. 1, 2, 3, 4, 5, 6. And if you draw 5 lines over here, that'll give you 6 spots over here. Okay, and again, just really pretend they're equal. 6, okay, and then we've got some green. Half of it is done. 11/12 total is painted. So then we've got, that'd be 6, 12, 7, 8, 9, 10, 11. So there's our blue chunk, there's our green. It's almost half and half, but it's not quite all the way painted. That's it, there's your visual. I was kind of expecting, I keep expecting that they'll say like, what part of it is left unpainted, but they don't go that deep this time. So maybe textbook writers, they're giving us a break. Page 140, number 2, Greta and Tran have the lead roles in the play. Greta's on the stage for 3/4 of the play. Tran is on the stage for 2/3 of the play. What is the difference between the fractions of the play that Greta and Tran each spend on stage? Draw a visual model to represent the difference. Okay, so here we go again. We've got the one whole play, right? And then Greta's on stage for 3/4. So let's do, oopsie. We'll do this. Half, split your halves in half. Those are your fourths. Okay. So if you want to label them each like a fourth, a fourth, a fourth, I'm just going to color this in. 1/4, 2/4, 3/4. Okay, and I'm going to put a letter here, V for Greta. Okay, Troy is 2/3. So if that's the whole thing, sorry, this one got kind of narrow. So we got 1, 2, and I'm going to color that one in a little differently. Sorry, Tran, you're getting pink. Okay, so Tran, T for Tran is 2/3. Ooh, okay, the way that I set this up, sorry, that should be colored in up here for the green. Okay, there's our visual model. Okay, yep, this one, they're checking on the difference. So, oh dear heavens, I think I need to scroll this down and kind of redo it. Okay, you can totally fast forward this because how lame. Sorry about that. Okay, roughly like this. Okay, so that's our one whole thing. That'd be about half. There's 3/4. Here's roughly, oh, I don't like that. About here is 2/3. Okay, so 1/4, 2/4, 3/4. Here's our thirds. This time I didn't include like that last third chunk there. Okay, so this teensy little bit right over here represents the difference in the time that they're on stage. How do we figure that out? Well, think about when we've got fourths and we've got thirds. What is a common denominator we could use? Yeah, very good. 12ths, right? Count by 3, count by 4. We end up with 12. So if you split that like thirds into 4, and if you split 4 into 3 different pieces, those would be 12ths. And look at this, like pretend my stuff is beautifully perfect, right? That is actually 1/12. So our answer is 1/12, and then our label is of the plate. Our labels are getting a little more complicated. So rather than inches or chickens or cats or meters or something, we've got of something, like of the salary, of their earnings, of the play. Okay, so just pay attention to that. It's a little tricky, but you're doing well. Okay, this one says use a visual model to find the difference. I'm just going to say find the difference, okay, because we do lots of visual modeling, and you can do this if you want extra practice with it, but let's just practice our common denominators. So with 12 and 3, I can leave the 12 alone and take the 3 times 4 to get it over 12. Whatever you do to the denominator, you have to do to the numerator. So we've got 11/12, and we're going to take away 8/12. We have 3/12. Okay, you can divide both of these by 3. Okay, so our true answer, 3 divided by 3 is 1, 12 divided by 3 is 4. Your true answer there is 1/4. And if you did not practice simplifying that, please do so now. Okay, number 4, 3/5 minus 3/10. 10 is something that 5 goes into, so I'm going to take advantage of that and use 10 as the common denominator. When you use your least common multiple, you have less simplifying to do later, so it saves you steps in the long run. But if you do it a different way, you can still end up with the same answer. Okay, so here we have 6/10 minus 3/10. Okay, 6/10 is the same as 3/5, just kind of like how 2/4 is the same as 1/2. We're just making it look different. We're talking about like different size chunks of a fraction. Okay, 6/10 minus 3/10. We're still talking about tenths as the size, and then we have 6 of them. Take away 3, we have 3 left. Number 4 is 3/10. Number 5, 9/8 minus 1/4. We've got an 8 here. I can easily turn my 4 into an 8 just by doubling it. You have to do the same to your numerator because 1/4 is not the same as 1/8. Okay, they're actually, it's half the size, right? So 1/4 is the same as 2/8, but just be very careful there. Okay, so you have to change your numerator if you're changing your denominator, or you are not doing the same problem. 9/8 minus 2/8, 9 minus 2 is 7. You've got 7/8 there. Number 6, Hannah prints t-shirts for everyone working on the play. Her printing machine uses 1/2 milliliter of ink for each shirt. The front of each shirt uses 2/5 of a milliliter of ink. How much ink does the printer use for the back of each shirt? Alrighty, we've got 1/2 and we've got 2/5, right? So they use 1/2 every time she prints a shirt. The front of each shirt uses 2/5. So we're going to take away that 2/5 for the front, and then what's used for the back? I'm going to switch my color for you here. So let's take the 2 times 5 to deal with tenths. Take the 1 times 5. Sorry, this is as neat as I can be. I'm really trying. Take your 5 times 2 to make it over 10. Take the 2 times 2. Okay, so then we're going to take away this. I just rewrote over there. 1/2 is the same as 5/10. 2/5 is the same as 4/10. We're just making it manageable for this problem. 5/10 minus 4/10 is 1/10. And check your label here, milliliter. And the abbreviation for that is M, lowercase m, capital L. Awesome. Good work, Mustangs.